हेलो हाय हे गिद्या हाउ आर यू ऑल। तो कैसे हैं आप लोग। वेलकम बैक टू सेशन नंबर 6 ब्रिज कोर्स पावर्ड बाय बेस एजुकेशन। आई एम योर केमिस्ट्री टीचर आदिल खान। I would like to welcome you all in the session number 6. Hope session number 5 is crystal clear, smooth like makhan. So let's take first the question of the day from the session number 5 and then we'll move to session number 6. Let's move. Today, bad throat, so please excuse me. Question of the day from session number 5. Let's take it quickly. Find out the percentage composition of carbon in carbon tetrachloride. So carbon tetrachloride, you know the formula is CCl4, where carbon atomic mass is 12, chlorine is 35.5 or 35, you can take it. So percentage composition we have to find out of carbon. Carbon mass is, formula is mass of the element by total mass into 100. So mass of the element is 12. Why? Because it is carbon. So carbon tetrachloride, so 35 into 4, 70, 140. So close to how much it will give? It will give you around 154 if I am taking 35.5. So 154, 12 by 154 into 100, we are calculating the percentage composition of carbon from here. So tell me what will be the answer. So when you see it look slight lesser than 10, close to 7 point something, between 7 to 8. But if you want to know the exact answer, it is close to 7.8 percentage or 7.78 or 79 something. So this is the percentage composition of carbon in carbon tetrachloride. Carbon tetrachloride is a type of polyhalogen compound, which means there are more than one halogen linked with carbon. It's an important solvent in pharma industry, just for your knowledge. Let's move to the second question. Find out the percentage composition of nitrogen in urea. So urea, the formula is NH2, C double bond O, NH2. Just for your knowledge, urea is the first organic compound to be prepared in lab. Before that, it was always believed that organic compounds are produced from living organism, but first time it was produced in lab. I will teach you more on this in the organic chemistry. So find out the percentage composition of nitrogen in urea. So you are finding out the percentage composition of nitrogen. So nitrogen, there are two nitrogens, so 14 into 228. 14 into 228. For two nitrogen atom, and 28, 30, 32, 12, 36, 48, 16, close to 60 it will come, or around 60. And now you calculate how much you will get from here. Close to 50, around 48 something you will get. Exactly find out how much you get. 28 by 60. So 28 by 60, 14, 37, 15, close to 47%, or to be precise, 46.7%. This is the amount of nitrogen which is present in your urea. It's an important fertilizer used by our farmers to grow better yield of crops. Next one is find out the percentage composition in oxalic acid. Oxalic acid presence is seen in tomatoes, just for your knowledge. So oxalic acid is a diacid, organic acid basically. Why it is diacid? Because there are two COH groups. So this is your oxalic acid. It is telling you to find out the percentage composition of oxygen here. Sorry. So there are four oxygens here, OOO. So 16 into 32, 64. Find out the total mass of it. Oxalic acid, I believe you know how to calculate the molar mass. Find out the total mass. It will be less than 100. 24, 24, 64 and 2. Quick, and tell me the final answer also. How much? 90, right? Correct. Sometime you will see the formula of oxalic acid as this formula .2H2 as water of crystallization. I am not giving you the dihydrate form. I am just giving you unhydrated form of oxalic acid. Now 64 by 19, tell me the answer quickly. Close to 71% it will be. So calculate, I think it is closer to 71%, the percentage composition of oxygen in oxalic acid. Fourth one, you have to find out the equivalent mass. Equivalent mass concept we have discussed last class in detail. What do you mean by equivalent mass? I have given you example of friends eating samosa, dhokla and all those things. I hope you can recall. Find out the equivalent mass of H3PO4. So when you calculate the equivalent mass, I am just writing it as EQ, or E also I can write it. So before that, you have to calculate the molar mass of H3PO4. So I think I have given you once. It is similar to that of sulfuric acid. What is the mass of sulfuric acid? 98, correct. So similar to that, this is 98. So you will be writing the total molecular mass 98 by since it is an acid, so you have to look for how many H plus ions it is producing. So for that, you must know the structure of H3PO4. Total 3 H plus ion it will generate. By looking at the structure only, you can identify this. I think we have discussed the structure of this in the previous session, that how it looks. Just for your knowledge, this is phosphorus. 4 oxygens are there, so double bond O, OH. This is the second OH, and this is the third OH. Basically, the hydrogen is acidic in nature when it is linked to oxygen and when it come out as H plus ion. So 3 H plus ion, you can see that it can come out. So keeping that into mind, what happened to the pen? Come on, yeah. So 98 by 3, how much it will give you on a rough scale? Close to how much? 48? No, 30 something? No, 30, yeah. So it will be giving you 32 point something, that is the gram equivalent. So you can calculate that part. This is with respect to your H3PO4. It is a oxo acid of phosphorus. Oxo acid basically means when the element like phosphorus or sulfur is containing oxygen and hydrogen, where hydrogen is linked to oxygen, that is known as oxo acid. And the last one is find out the equivalent mass of sulfur in sulfate ion. So sulfate ion, for your knowledge, is SO4 2 minus ion. When you join college, we will discuss all this in lab for you also. Calculate the mass. So oxygen is 4 times 16 into 4 is 64, and sulfur is your 32. So calculate the overall marks. It will be slightly lesser than that. So it will be around 96 if I'm not wrong. Correct na? Correct. And what is the N factor or the valency factor what you're using? So here the N factor or the valency factor, this 3 I got it by keeping in mind my 3H plus ion which is coming out. Here the valency factor is nothing but the charge which is present on the anion or the cation. Since it is anion here, so you are going to divide it by 2. So how much you will get? I think it will be close to 48 exact. So 48 gram equivalent, just for your knowledge. That's how you calculate the percentage composition and equivalent mass of either acid, basis or ion like that. So I hope session number 5 question of the day is clear. Let's start with session number 6 for the day. I'll give you a hint. What do you mean by session number? What is there in store for session number 6? Couple of years back, if I'm not wrong, 2017-18, there was a movie of Mr. Akshay Kumar in Bollywood. A good movie with good information given to the society. That movie name was Padman. And there was a very good, very sober song that तेरे कांधे पे जो तिल है और तेरे सीने में जो दिल है और तेरी बिजली का जो बिल है वो मेरा हो गया. Okay, I'm repeating it again. तेरे कांधे पे जो ये तिल है, कांधे is there, sorry. तेरे कांधे पे जो ये तिल है, तेरे सीने में जो ये दिल है और तेरी बिजली का जो बिल है वो मेरा हो गया. Akshay Kumar was singing this song. 3 important things are there: dil, bill and till. So what is the new concept of session number 6, my dear friend? If you are still not able to get it, hi, can you identify this friend? What is the name? Cylindrical body, velvet fur is there, Eyelids are very small and not properly developed. One of the best digger of the world. I think they can dig around 15 meters per hour. That is the speed of digging. The male gender of this gentleman is known as something else. The female gender is known as something else. With velvet and cylindrical fur, ladies and gentlemen, please welcome Mr. Mole. So the today's topic is mole and mole concept. Sir, गाना वाला समझ में नहीं आया. तेरे कांधे पे जो तिल है, till is a Hindi word, Devanagari script, which means mole in English. So that till wala mole, this animal wala mole, and the mole concept wala mole. So ladies and gentlemen, please start. Let's start the new topic, that is mole concept. Now, if I tell that, what do you mean by couple of pen? Couple of pen means two pen. Suppose this is my red color, this is my blue color. Suppose similarly, if I tell a dozen of pen means how many pens? 12 pen. If I tell Virat scored century in last match for RCB, century means how much? 100, right? So these numbers are very specific, whether Virat scored the century or Rohit Sharma scored the century or our KL Rahul scores the century. Century means 100. Similarly, dozen means 12. 1 dozen banana, 1 dozen monkey. 1 dozen banana is 12 banana. Maybe the weight will be 1 kilogram. But 1 dozen monkey will be 12 monkeys and the weight may be 20-25 kilograms. Mass are different, but number you have to remember. So since 1 couple means 2, 1 dozen means 12, century means 100, in chemistry, dozen mole means a specific number. For example, 1 dozen means 12. Nah? The 12 is a number, 12 number. Similarly, 1 mole means 6.022 into 10 to the power 23, and this number is known as Avogadro number. Couple means 2. That number 2 name is TWO2. Similarly, 1 dozen means 12. Okay, 1 dozen means your 12. That 12 name is there. Similarly, 1 mole means 6.022 into 10 to the power 23. The number, that number name is Avogadro number. Before I start, okay. Mole concept and Avogadro number. In the previous sessions, I discussed many times that atoms are too small to measure or to even count, or to find out the relative weight also, it is not sometime feasible. So in our day-to-day life, we know the term pair means 2, dozens means 12, century means 100, etc. are used to count the number of particles irrespective of their nature. Nature means if I tell 1 dozen river, India has so many rivers. Ganga ji is there, Yamuna ji is there, Kaveri is there, Ravi is there, Brahmaputra is there, Gandak is there, Kosi is there, Jhelum is there. Then you have Shwanarekha is there. Like that, many rivers are there. So 1 dozen river means 12 river, but 1 dozen lakes also means 1 dozen lake, right? Bangalore is used to be known as the lake city, but river is so huge, lakes are small. Natures we are not counting, we are just counting the number. So number is more important. For example, 1 dozen banana means 12 banana. 1 dozen water bottle means 12 water bottle, irrespective of their size or the weight. Dozens refer only to the number of the object. So number is more important. Similarly, mole means a specific number. That number is 6.022 into 10 to the power 23. A huge number. After 6.022, 23, the 23 zeros are there with 6.022. So in a similar way, for counting atoms, molecule or ions, basically the small things, atom, molecule, ions, electrons, the chemists use the unit mole. It is also known as chemist dozen. Chemist dozen. The term mole is a Latin word, Latin origin, which means heap or pile. You tell no, the pile up the pancakes together or put the heap of tablecloths or the bed sheet together. So mole in Latin means heap or pile. A mole is defined as the number of atoms in 12 gram of carbon-12 isotope. This concept we know. So the definition of mole is, it is defined as the number of total atoms present in 12 gram of carbon 12 isotope. The 12 part I divided once. You remember session number, the previous session. Okay. The number of atoms in 12 gram of carbon 12 was found to be 6.022 into 10 to the power 23. So there was an experiment conducted where the charge on the electron, the mass of the electron, and all those factors were considered to come to this number. This is the experimentally derived number. So 12 gram of carbon 12 contains 6.022 into 10 to the power 23, represented by capital N and capital A as the subscript, or capital N or the subscript will be 0. So Na or No is the representation of this. If I write for you, it can be also represented as No, capital N, or like this. So this number is known as Avogadro number. So there was a Italian chemist. His name was Avogadro. So this number was named after him. He didn't discover this number. This number was discovered by Jean Perrin. Okay. This number was discovered by Mr. Jean Perrin. RRIN. But the initial work on carbon was done by Mr. Avogadro. That's why, in order to give honor to him, the number was named as Avogadro number. But it was not discovered by Mr. Avogadro. It was discovered by Jean Perrin. It was just given in honor of Mr. Avogadro. Avogadro has a very big name. His name is Lorenzo Romano Amedeo Carlo Avogadro. A very big name, but in short to remember is Amedeo Avogadro is the name of this. So Avogadro number, just for your knowledge. Just remember that whenever we tell 1 mole, you are going to remember this number. Whenever we tell 1 dozen, you are going to remember this number. Whenever we tell century, you are going to remember this number. That's the significance or meaning of it. Let's move further. Now, mole is a name given to a specific thing with a bigger number, 6.022 into 10 to the power 23. If 1 mole of marshmallow is there, so you know, close to, if I'm not wrong, 600 meters or fits, I'm not exactly remembering the value of thickness, can be filled in entire United States of America. That huge it is. If you have Avogadro number of hockey balls, then I think you can go from Earth to moon, and maybe probably you can come back also. You just can cross check all this. So a mole is basically what? A number. And this is the number, and it can be this many particles. Particles can be atoms, molecules, ions, or electrons. The symbol of mole is mol, M-O-L. For example, kilogram, it is kg. Milliliter, it is ml, the symbol. Similarly, mole symbol is mol, and it is equivalent to these many particles, 6.022 or 6.023. Both are acceptable for you. You can take either of that. Particles can be either atoms, molecules, or ion, or any other subatomic particles, small particles. Basically, it is helpful in calculating smaller particles, or particles are those things which has mass and charge. So mole is used to calculate smaller particle. For example, if I tell 1 mole of hydrogen atoms in India, then it will be 6.022 into 10 to the power 23 hydrogen atoms. Same thing will be repeated in Uganda and Nigeria and Laos also. Similarly, 1 mole of hydrogen molecule will be equivalent to 6.022 into 10 to the power 23 hydrogen molecule. If I tell 1 mole of hydrogen ions, it will be 6.022 into 10 to the power 23 hydrogen ions. If I tell 1 mole of electron, then this number of electrons will be. So 1 mole, either you can refer to atoms or molecules or ions or subatomic particle. Okay, so the moment you tell 1 mole, this number is fixed. The moment you tell 1 mole, this number is fixed. After that, whatever you feel like adding, you can add. For example, in a layman term, in just order to explain you, if I tell 1 mole of water droplet, it means 6.022 or 6.023. into 10 to the power 23 water droplets. Okay. So this is the weighing machine, a modern weighing machine, not that old one, what you see. So this is 12 gram. Basically, this is carbon. So this is carbon. Carbon atom mass 12. This is copper atom mass around 64, to be precise 63.5. In carbon atom, if it is 1 mole, then the number of carbon atom will be this much. Carbon atom, if it is 1 mole, then it will be 6.022 into 10 to the power 23 or 6.023 into 10 to the power 23 carbon atoms. If it is copper atoms, you know the mass of copper is 63.5. Mass is not that important, number is important. And 1 mole of this copper it is 1 mole of copper. Let's avoid this. So 1 mole of the copper will be equivalent to 6.022 or 6.023 into 10 to the power 23. So basically what I want to convey is 1 mole of carbon will be equivalent to this number and 1 mole of copper will be equivalent to this number. The mass is not important. The nature is not important. Whether they are light or heavy, that is not important. Whether they are solid, liquid, gas is not important. Whether they are metal or non-metals, it is not important. What is important is whenever I quote 1 mole, you have to tell 6.022 or 6.023 into 10 to the power 23 number. And after that, it can be anything: atom, molecule, ions, electrons, water particles, water molecules, etc. So I hope this part is also clear to you. Let's move to the next. Now, whenever you have mole, I think in the previous session also, when I was calculating molecular mass, for example, molecular mass of H2SO4 is 98 grams. Okay. 98 U. But if I talk about gram molecular mass, it was 98 gram. Now, if I change the unit from gram to gram per mole, it becomes molar mass. For example, H2SO4 molar mass is 98 gram per mole. Similarly, water molecule mass is 18 units. In gram, it is 18 gram. Similarly, if I represent in the molar mass, it will be 18 gram per mole. Okay, so they are closely related to each other. The molecular mass, gram molecular mass, and the molar mass. Molar mass, it is defined as the total mass of 1 mole of a substance. So 1 mole of a molecule, 1 mole of a compound, or 1 mole of a substance. Unit is gram per mole. Okay, gram per mole. However, the SI unit is kg per mole, but very rarely we use it. Why? Because we are using this for very small type of particles. So very small sizes of particle which you can't count easily. That's why we go with the smaller unit, that is gram per mole, and kg per mole is rarely used. So molar mass, the formula is, so molar mass you can calculate, suppose mm stand for molar mass. So we write the formula given mass by number of moles. Number of moles is represented by small n. So molar mass equivalent to given mass by number of moles. That's how we calculate formula. There are many more formulas for this. There are many more formulas for moles also. With time, I will give you a couple of them, not everything. So molar mass of any substance is mass of the substance in gram by the number of moles. Same thing is here. Example, molar mass of water is around 18 gram per mole. The moment you write 18 gram per mole, it is molar mass. If you write 18 gram, it is gram molecular mass. Okay. If you write 18 U, then it is molecular mass. Molecular mass, gram molecular mass, and molar mass, which is the mass of Avogadro number of the water molecule. So if I tell that I take water and its molar mass is 18 gram per mole, and I ask that how many water molecules are present in this, it will be equivalent to Avogadro number. Avogadro number is 6.022 into 10 to the power 23. To be simple, you can write it as 6.023 also. Similarly, if I take 1 mole of methane gas, also known as marshy gas, the molecular mass or the molar mass for this is 16 gram per mole. How 16? 12 for carbon and 4 for hydrogen, 16. Now, how many methane molecules are there? Again, here the methane molecules is Avogadro number, 6.022 into 10 to the power 23 methane molecules. That part is clear. For example, if I give you another example of ozone, which is O3. If you calculate the molar mass 16 into 3, how much it will give? 48. So 48 gram per mole. This is molar mass. How many molecules of ozone will be there? Avogadro number of molecule. So what I mean to tell is, if you know the molar mass, you can directly equate with the mole or Avogadro number. It is easy to equate. They both are almost equal. Now, this is a type of diagram which will help you to get the various different type of formulas which involve number of moles, which is represented as small n, mass in gram. Basically, this is the given mass, and this is the number of molecule. So if you take number of moles and multiply by molecular mass, you will get this. If you take number of moles, multiply with molecular mass part, you will give that. So this will basically give you the various different type of formulas. You just note it down at this point of time. When you come to colleges, when we teach the first chapter, some basic chemistry, some basic concepts in chemistry, there this topic will be dealt in depth. Here I just want to convey you that there can be interconversion between number of moles, number of molecules, and mass in gram. That is a given mass. You can multiply them or divide them to get various type of permutation and combination with respect to formulas. At this point of time, I want you to understand 4 formula. Let's go and discuss that. How many ways we can calculate moles? So there are multiple ways. These 4 are for you. So number of moles is basically what? Weight and mass is considered same in chemistry. Number of moles is weight in gram by atomic mass. This is basically when I take atoms. Suppose I am calculating number of moles of hydrogen atom, then this concept I am going to use. Number of moles, which is represented as small n, is weight in gram, the given mass basically, and the molecular weight or molecular mass, and this is for molecules. So number of moles you can calculate for atoms and molecules. For ions also you can calculate. So number of moles, the representation is small n, weight in gram or given weight, and the ionic weight or the formal weight. Ionic weight means, for example, just now today I have discussed, no, for sulfate ion. Okay. Similarly, for carbonate ion, you can calculate the weight. Carbon is 12 and oxygen is 3 times. So 16 into 3, that is 48. You can calculate accordingly. Okay. So weight by ionic weight. Similarly, number of moles you can even calculate. These are for solids. Solid means you can calculate the mass. Atoms, molecule, or ions. This is for ions basically. It can be cation or anion. Number of moles in the gaseous state. So basically volume at NTP and 22.4 liters. NTP stand for your normal temperature and pressure. There are 2 type of situation. One is known as STP, standard temperature and pressure, and one is called NTP. So in these 2, pressure, volume, and your temperature, they are important. In NTP case, we are taking the room temperature. Okay. Room temperature. Basically in European countries, it is 20 degrees Celsius. And in the continents like Africa and India, it is 25 degrees Celsius. So temperatures are variables in case of STP, NTP, pressure, and the volume wala part. So NTP is your normal temperature and pressure, which is around room temperature. And the volume we take it as 22.4 liters, and pressure will be 1 atmosphere or 1 atm, the unit of pressure. There are multiple units. This is one of the unit of pressure. So I expect you to remember these 4 formulas because it will help you in future when we discussed about your moles much in detail. In the offline classes, mole will be dealt in much detail. Now, can you see this too? This is the end of part 1 of your session 6. Part 2 I am just doing for you. In 10th standard, I'm giving you one hint. In CBSE, the first chapter is this. This is elephant toothpaste wala experiment. Can you recall? And this is sodium in water wala experiment, exothermic. foam is produced. What these two signify? This signify reaction. This also signifies reaction. I'll have water, just a sec. So it signifies a type of reaction. It signifies the type of reaction. So the next topic is the various type of reaction which you see in chemistry for your level. Multiple reactions are there. Combination reactions are there. Decomposition reactions are there. Displacement reactions are there. Simple displacement or single displacement and double displacement reactions are there. You have neutralization reactions. You have redox reactions where the electrons and ions are involved. You have precipitation reactions where solids are formed when you mix two things in the liquid form. And various other things are there. I'm not going much in detail of all those. Whatever is required for you, I will be just doing for you. So types of reaction, and this is the general reaction, how we represent. So first one is your combination reaction. Another name for this is synthesis reaction. So combination reaction is what? When you have two reactant A and B combined to give only one product, that is AB. And one important thing what you see here, that here bond formation takes place. Okay. So we see bond formation here. Basically the covalent bond we are talking about. So this is combination reaction. In detail, I will discuss after some time. Then you have decomposition reaction or analysis reaction. So here we use one reactant and it break down into your two different simple products. And in this case, bond breaking we see. And whenever bond breaking is involved, you need some external source like heat is required, pressure is required. Heat can be in the form of the sunlight or the normal heat what you give. Next one is displacement reaction, replacement reaction or substitution reaction. So this is your one reactant A, this is your molecule BC, another type of reactant. So what we see here is that A is combining with C and B is coming out. Basically a displacement type of reaction, single displacement. Next you have double displacement reaction or double replacement reaction or metathesis reaction. Basically here A and D they are combining and B and C they are combining to form AD and CB. So bond breaking is involved, bond formation is also involved at the same time. Then you have combustion reaction. Combustion reaction is basically a reaction which is done in the presence of the oxygen. One concept I'm telling you now, you take any organic things in the world, you take me, you take dog, you take rat, you take elephant, you take trees, you take vegetables, you take fruits, you take fur, you take skin, any organic things. If you burn in the presence of oxygen, air, in the excessive amount of air, you always get four important products. They are carbon dioxide, water vapor, heat and light. So any organic compound, when you burn or do a combustion of that in the presence of excess amount of oxygen supply, you get carbon dioxide, water vapor, heat and light. If you use less amount of oxygen, carbon dioxide, in place of that, you get carbon monoxide, which is a silent poison. Why it is silent poison? Because it go and combine with hemoglobin and kill you slowly, carbon monoxide. So combustion reaction takes place in the presence of oxygen. When you supply heat, delta means heat, it forms water and carbon dioxide and heat and light. If this oxygen is less in amount, in place of carbon dioxide, you get carbon monoxide. Then you have acid-base reaction, which is also known as neutralization reaction. Acid and base, when it combine, it gives salts and water. We have discussed in the previous session, so you know in detail about this. Next type of reaction is precipitation reaction. Precipitation reaction basically means what? There will be a soluble salt B and there will be a reactant A. So when they react, a solid is formed. A solid is formed as a precipitate and soluble salt of C is formed. These all things you will be doing in detail in your lab, chemistry lab in the first year and second year. First year around 6 to 8 salts, we will be giving you simple salts made up of one cation and one anion. And second year you will be having again close to 10 to 13 salts. And there you will see how precipitates are formed: white color precipitate, yellow color precipitate, and very pale yellow color precipitate, and various other colors depend on which all elements or ions are involved in that. So these are the types of reaction which we are discussing a bit in this bridge course. So let's move. Combination reaction, a reaction in which two or more reactant combine to form a single product. So this is important. A single product it will give, and there is a bond formation which is very much important. Representation is X plus Y. It will give you XY. So it is like this. Generally it is a single bond, but in organic chemistry you will see double bonds are also there. Triple bonds are also there. 4 bonds are there? No. For your level we don't study the 4 bond. And in future, I will teach you that this single bond is known as sigma bond. And when double bonds are there, one will be sigma, one will be pi. When triple bonds are there, one will be sigma and two will be pi. So sigma bonds are like parent. Generally, you have only one parent, every one of us. I'm not talking about the Western culture, but in India, in our culture, generally we have one parent, one father, one mother. So that father and mother signifies sigma bond. But father and mother, they can have 2 kids, 3 kids, 1 kids. So accordingly, pi bonds are considered as kids and sigma bonds are considered as the parent bond. So combination reaction is also known as synthesis reaction because it is producing a product. So when I take sodium and chlorine, it produces 2NaCl, which is ionic in nature. This is ionic compound. Why ionic? Because it is between a metal and a non-metal. And carbon and oxygen, when it combine, it gives rise to carbon dioxide. This is the covalent molecule because it is formed between 2 non-metals. A slight more information, it further break it as Na plus and Cl minus. So this is your cation and this is your anion. Whereas carbon dioxide is not going to break like that. In future, in chemical bonding, we will be teaching you what will be the shape of carbon dioxide. Okay, I don't think you know much detail. So it will be linear like this. So there will be 2 bonds here, 1 sigma, 1 pi, 2 bonds here, 1 sigma, 1 pi. Why? Because you have to keep the valency and all in mind. That's why. And later in detail we will do that. So this is covalent and this is ionic. Covalent bond is represented by a solid line. And ionic bonds, basically it is a force of attraction. It's a force of attraction. So dotted line, dotted points and all, we can represent or we can avoid also. Generally we avoid, generally we don't write anything there. Decomposition reaction. The word also, decomposition means that you are breaking. So in this what we do, a single product is there, which is having a bond between them. You supply some condition, temperature, pressure, like that. It will form 2 different products, simple products, X and Y. X and Y. So X, Y break into X and Y. So this is known as decomposition reaction. It is just opposite of your combination reaction. So combination reaction was X plus Y giving that, and this is XY product molecule giving X and Y in this case. The reaction in which compound decomposes due to heat is known as thermal decomposition reaction. So if you apply heat, which is represented by delta, it is known as thermal decomposition reaction. But if you apply sunlight, then which is represented as H nu, or we also write it as ultraviolet, then it is known as photo decomposition reaction. Photo means light, and various other things are there. Example is you take calcium carbonate. When you heat it, it forms calcium oxide and carbon dioxide. Calcium carbonate, where all you see? Limestone. Correct. Eggshell. Correct. So calcium carbonate is there. So this is your decomposition reaction. There are various other reactions. I think you know all that. I am not going in detail and discussing the types of examples. Next one is single displacement reaction or displacement reaction. For example, you goes to someone's house and there they have given you Maggie to eat, your friend or relative house, and along with Maggie, if they give you, there is a combination of Maggie and vinegar and Maggie and tomato ketchup, what you will use? So if suppose someone by mistake has added vinegar to that, In order to compensate, you will add more tomato ketchup so that tomato ketchup flavor is enhanced and vinegar is reduced. So what you are doing, you are displacing the flavor of the vinegar using tomato ketchup. Just a common example. So our displacement reaction, it's a chemical reaction in which more reactive element displaces a less reactive element from aqueous salt solution. So one important criteria here is the reaction must take place in the solution form, and it must be in the aqueous salt solution, that is in the presence of water as the solvent. And the more reactive thing replaces less reactive thing. You remember tomato ketchup and the vinegar example. If you take 10 individuals in India of age group 16 to 18, 7 to 8 of them will like tomato ketchup, only 2 will like the vinegar flavor. So if 8 of them are liking the tomato ketchup, it means they are more reactive towards it compared to the vinegar part. Suppose my X is more reactive. So my X will go and react with Z and Y will come out. Now here one thing you have to notice is that X and Y, they must be of similar type. It means they will be metals. So one metal will be displacing another metal. Okay, generally it is like that. It's not like that you will take a metal which is going and displacing a halogen. It's not like that. Metal will displace a metal. Eatable is displaced by something eatable. For example, you have coffee. Suppose there is water and there's an option of tea, you will take tea. You have tea and there's an option of coffee. If you get coffee and you like coffee, you will take coffee. So you are replacing drinkable with drinkable. It's not like that pizza is there and you have dal rice and you haven't had pizza in 1 year. So obviously you will go ahead with the pizza part. So eatable things is replaced by eatable. Similarly here, metal is replaced by metal. It is also known as substitution reaction. For example, if Messi and Ronaldo, they both are playing together, first 45 minutes Messi, second 45 minutes Ronaldo, or vice versa, it's like that. So here I take a more reactive metal zinc. It is reacting with the less reactive metal copper. So zinc and coming and reacting with sulfate, copper will come out. So it will give you zinc sulfate and copper. How you know zinc is more reactive and copper is less reactive? There's a series known as reactivity series or metal reactivity series, where metals are arranged in a order from top to bottom in such a way that highly reactive metals are on top and low reactive metals are at the bottom. There are 3 types of metals for your level. First type, highly reactive metals. Without any if, but and question, they react by giving out electron, like lithium, sodium, potassium, like that. Then you have moderate reactive metals, which thinks and react whether I have to react or not. Example, iron, tin, like that. Then you have less reactive metals like Mr. Amitabh Bachchan, that you go and tell Mr. Amitabh Bachchan, you are not looking good. You are aged now. Your voice is not that great. He will not feel bad because he's a noble person. He will not react. So copper, gold, silver, platinum, those type of metals, they are less reactive. You people are at the age group of highly reactive humans. For example, if someone come and tell that, hey, today you are wearing black color jeans, I think it is not the jet black, it is charcoal black, you will feel bad. You're highly reactive. You will go and tell your father and mother, I told you to buy me jet black jeans, but I got a charcoal black or ash color jeans. Now, when you become parent in future, when you will have kids of your age, at that point of time, you will be moderate reactive. If someone come and tell you that, hey, your pant color was black, but now it is faded to gray color. Depend which person is that. If a person is unknown, you will tell, go yeah, no problem. But if someone closer to you tell that, sometime you feel bad. And then when you become grandparent and all, that time it doesn't matter. That most situation you will be in. That someone will come and tell that your pant color is not good. You will tell, yes, it is not good, no problem. So we humans also are in 3 phases: highly reactive, under the age of 20-25, moderate reactive between the age of 20-25 to 40-45, and when we became grandparents and all, we are super matured, so we are less reactive. So metals are arranged in increasing order of their reactivity, and that series is known as metal activity series. I want you to know this series. So the most reactive metal is on the top and the least reactive metal is in the bottom. And when you are coming down, the reactivity is keep on decreasing. Reactivity is decreasing. Lithium is more reactive, followed by potassium, barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, and lead. They are moderate reactive. Copper, mercury, silver, gold, platinum, they are least reactive or they do not react. In between them, there is a hydrogen, which is a non-metal. Hydrogen is not a metal, it's in the gaseous form. Metals are generally solid with the exception of mercury, which is in the liquid form. Hydrogen is a gas. Hydrogen is a reference metal. So it is dividing the entire reactivity of metal. Above side, everything is reactive. Bottom side is everything is non-reactive. How you can tell that? Above this, whatever you take, when you make them react with acids, it will produce hydrogen gas. Okay, and below this hydrogen, whatever is there, when you make them react with acids, they will not produce hydrogen gas. So this is my reference point to study the reactivity. Above this, everything reactive. Below this, everything non-reactive. But here relative reactivities are there. Lithium is more reactive than potassium. Potassium is more reactive than barium. Barium is more reactive than calcium. But between calcium and lithium, lithium is more reactive. Okay, so various books, they have various different type of orders with slight fluctuation in above. So till last year, I used to teach like this: Lily, Cat, Nam, Magnet, Alu, Jeera, like that. But I think this series is not fitting in that. So I am not giving you that. So you create your own shortcuts. And when you meet us in offline, we will also give you the few shortcuts. So nutshell, there are three type of metals: highly reactive, moderate reactive, less reactive. Highly reactive metals, they react without taking note of anything. Moderate reactive, see the situation. Less reactive, they don't react at all. In displacement reaction, the metals which is above can react with the metals which is below. You remember just now I quoted example of zinc and copper. Let's see this. Now my zinc is above, okay, highly reactive, copper is below. So that's why this can react with copper, but copper can react with zinc, no. Metals which is above can react and displace metal which is in the bottom part of the reactivity series, but the metals which is in the bottom part, it will not go and react with the above part of the metal reactivity series. For example, sodium can react with tin, possible, but tin, can it react with sodium? Answer is no. Not possible. For example, I take zinc and I take gold. Zinc can go and react with gold. Yes, it can replace gold easily, but gold can react with zinc. Answer is no. Reason, gold is less reactive. Okay, and these all reaction takes place in the aqueous solution. You have to make salt, and that salt must be in the dissolved form, then only it will react. For example, in the previous case, copper sulfate is a salt form. Okay, good. Now let's discuss double. Okay, now this is a metal reactivity series. Again, you can avoid this part. These all things in future we will discuss. Now lithium, less reactive, lithium, sodium, and your potassium is there. So you can see that. Let's go back and check once. So lithium, potassium, and sodium wala part. Lithium, you see here the fumes, reactivity part. Potassium you see here, and the sodium part you see. They are reactive, but the reactivity is very relative. One will react faster, one will react slower. And reactivity also depend that in which state they are reacting, whether in the aqueous state or solid state. Solid state generally they don't react. So this is your reactivity of metal. So these all signify reactivity. That this fumes, what is coming, it is a reactivity fumes basically. whenever fumes are generated, it means reactions is going on. So I just want to convey that how the reaction looks if you see visibly. So this is the GIF for those reactions. Next one is double displacement reaction. You see this GIF first. So there's a bigger atom, a red one's 3 smaller atom, and one purple color smaller atom. Here gray and green color. So they are displacing each other. Basically green is combining with this gray, and this gray is combining with purple and the red color. So this is again on the basis of the reactivity series only. So double displacement reaction, a chemical reaction in which ions get exchanged between the two reactant, which forms a new compound. It is known as double displacement reaction. So basically the reactions takes place in ionic form. I will exhibit and show that. For example, X, Y, Z, A. So X and Z react and Y and A react to form this. It is known as metathesis reaction. What do you mean by metathesis? Find out that part. Less spoon feeding from here onwards. So barium chloride and sodium sulfate, when you check. So when I take barium chloride in aqueous solution, it will be in barium ion form and chloride ion form. And when I take sodium sulfate in the aqueous solution in the presence of water, sodium as cation and sulfate as anion. They react keeping in mind the valency. Now these two will react. NaCl, it is NaCl, 2 sodium are there and plus and minus, they are balanced. So 2 times. So you can just write it as NaCl. Similarly, Ba2 plus and SO4 minus. So this and this react. Metals we always write first. So BaSO4. This is 2 plus and this is 2 minus. You do crisscross and all. Since the charge is same and the magnitude, the value is same, we avoid writing crisscross. I skip that step. Later it forms barium sulfate. So they react in the ionic form. Barium and sulfate react to form this. Sodium and chlorine react to form this. Similarly, many other reactions are there from here. You can refer your modules when we give you. Next one is precipitation reaction, a beautiful reaction. You can see some beautiful colors here. This is a GIF if it is not that visible. So when sodium chloride is added to silver nitrate in lab, you can do this. A white color precipitate is formed here. Can you see here? Turbid white color precipitate that is formed. This is the real GIF. White color AgCl is formed. So what is precipitation reaction? A chemical reaction which involves formation of insoluble product or a solid or a precipitate known as precipitation reaction. The reactants are soluble, but the product formed would be insoluble and separate out as solid. So in one test tube, there will be one clear liquid sample. In another test tube, there will be another clear liquid sample. When you add either 1 in 2 or 2 in 1, when they mix, initially they both were soluble. When they mix, it separate out as solid, and that solid is nothing but precipitate. Example here, sodium chloride in the aqueous solution. It is clear, no color is there. Silver nitrate, it is almost colorless, no color is there. When you add them, silver and chlorine will react, and this is precipitate. So we write precipitate like this. For example, if I write AgCl, I write downward arrow. This downward arrow signifies precipitate formation. Upward arrow signifies gases escaping out or coming out. So it is like this. And similarly, sodium and nitrate, they will react. And this is the clear form. This is white color precipitate. So different colors can you see here? This is white color. So this can be your AgCl, which is formed. Now, this is your pale yellow color. So this will be probably for silver bromide. In place of chlorine, if you use bromine, silver bromide formed. And this will be for iodine. That is when you form silver iodide. There are 5 types of halogens: chlorine, chlorine, bromine, iodine, and astatine. So if you are using chlorine, then it will form white precipitate. Bromine, pale yellow precipitate. If you're using iodine, it will be yellow precipitate. Everything from here will be done in lab so that physically you can see. So this is the color of the precipitate. It looks very beautiful when you do in lab. This and flame test, they look very good. Flame test, for example, when you take barium salt and put on the flame, it will give you grassy green or apple green color. For example, you take strontium salt, mix in acid, concentrated acid, and introduce to flame, it will give you crimson red color like blood. Very beautiful. So flame test and precipitation, they are visibly very good. It looks very good. So this is precipitation reaction. Now, if suppose the reaction takes place in the ionic form, they are molecular reactions in the molecular form without any charge, NaCl, AgNO3 like this. But if it takes place in the ionic form, for example, a reaction take place like K plus any random thing, K plus or I minus, it is giving you Ki, then this type of reaction is known as redox reaction. K and I you will get from something, either from KCl or HI. This is just a basic example. So redox reactions is a type of reaction, redox. It's a combination of two reactions, reduction plus oxidation, redox. We will teach you all this. Redox basically means someone is giving out electron and someone is accepting electron. So loss of electron, there is a concept known as OLE. OLE stand for oxidation loss electron. So whenever you undergo oxidation, you lose electron, and RGE, that is reduction, gain electron. So if you're undergoing oxidation, electron is lost. If you're undergoing, if you're undergoing oxidation, electron is lost. If you're undergoing reduction, electron is gained. Combination of those two is redox reaction. And whenever there is electron lost and electron gain, we call those type of reaction as redox reaction. They are in ionic form, just for your knowledge. So I hope that's it for the day. I tried keeping this video within 1 hour because in the previous videos when I was doing a QC, it was overshooting the 1 hour time frame. So this is your question of the day. You can pause it and write it down. In the following reaction, identify what is X and mention the type of the reaction, what is involved here. Okay. So you can get different type of names also. If suppose two names you are getting, you write both the names. For example, combination reaction, displacement reaction and redox reaction, you can write like that. So that's all from my side today. So in today's topic, we have done 3 things. First, we discussed about question of the day. Then we discussed about mole concept. 2 things in mole concept, that mole is a number and that number is equivalent to Avogadro number. And just for your knowledge, Avogadro is not the person who discovered this number. It was discovered by Jean Perrin. And Avogadro is an Italian and all those things. Then we went back and discussed the different type of reactions. And we discussed around 5 type of reaction. Combustion reaction, I have given you example that if you burn any organic substance, for example, you take the raw mango skin or dried mango skin and a leaf, which both of them are organic, and burn them, they will give carbon dioxide, water, heat and light. And then we discuss precipitation and all. So that's all from today's session. Close to 1 hour of lecture is done. I hope this is clear. In bridge course, we are not going and filling your mind with multiple information. Rather, we want you to know those things where we will build your foundation when you join us in the physical classes. So that's all from today. Wherever you are, be happy, be safe, खुश रहो, आबाद रहो, जहां भी रहो. Respect your parent, love the young ones, love the animals, and don't waste this precious time, because it will, if you are utilizing this for 3 to 4 hours daily, it will help to make your 11th and 12th easy. And one last thing before I wind up, the moment you join 11th, till now your capacity to sit in class is 40 to 45 minutes or 35 minutes. In base classes will be of 1.5 hours. So make your body ready, your body clock ready to sit for 1.5 hours. And the faster you do this, the better you will be settled and you will see a good jump in your results. So tata, bye bye, take care. God bless you all, and sayonara.